We'll be doing group work 12, problems C and D. C in group work 12 states, if we consider only the 75 students from Professor Mayberry's section, then the mean amount spent on textbooks was $293.60 with a standard deviation of $185.80. Use this information to construct an approximate 90% confidence interval for the mean amount of money spent on textbooks by all Pacific students. Describe 3 reasons why your confidence interval is wider than the confidence interval in Part A. Problem C is almost exactly like problems A and B, but it's just combined together. In C, we have our sample mean, which is $293.60, and we know our standard deviation of $185.80, and our sample size is 75. So, like A and B, we need to find, first of all, in order to find our confidence interval, we need to first find. We know our mean, but we don't know our critical value and our standard error. So first we want to find the standard error. So we take the sample standard deviation, and so the equation for that is the population standard deviation. Divide that by the square root of the sample size. In this case, our sample standard deviation is $185.80, and we divide that by the square root of 75 because that's our sample size. So that would give us a value of 21.45. Now that we know our standard error, which also the sample standard deviation can fit in that category, the way we can find a 90% critical value is to look on our T-chart, and if we look on our T-chart, we will notice that the critical value for 90% is 1.645. So with that being said, we have everything in order to put it in the equation. So it would be 293.60 plus or minus 1.645 times 21.45, and the values that we come out to have are 258.31 and 328.89. So what this means is that we are 90% confident that the mean amount of money spent on textbooks by all Pacific students is between $258.31 and $328.89. It also states that we need to describe 3 reasons why your confidence interval is wider than the confidence interval in Part A. 3 reasons I put down: first of all, standard deviation is larger. Second, sample size is smaller. And third, and lastly, result of sample standard deviation is larger. Part D. So Part D asks, suppose that we were given the critical values of a T distribution with 74 degrees of freedom and instead use this more accurate information to calculate the confidence interval in Part C. Would the resulting interval be narrow, wider, or the same length as the previous interval computed in Part C? Briefly explain. What I put down was that since the T values are wider at the edges and sharper in the middle, you will have a lesser range of values.